Okay, we're doing some A2Pure notes. We are in Unit 5 and we're looking at functions, and here we're looking at the graph of an inverse function. Consider the function, this is just from our previous example actually, f of x equals x plus 3. So how does that look? It's a gradient of 1 and the y-intercept then is 3, so this is going to be this line here, and then the inverse of this one is x minus 3, again gradient of 1, so a parallel line to this one when it crosses in at minus 3. Plotting graphs on both functions on the same set of axes gives the line shown on the right. The graph of the inverse function is a reflection of f in y equals f of x. This is because for the point xy in the graph of the function, there is a point yx on the graph of f to minus 1. And this is a factor for every single function and inverse function. If you have any function, let's pick a random one, say maybe that looks like this, and you want to find the inverse function, if you reflect the original function in the line y equals x, then that actually gives you the inverse function. It's always a reflection of the line y equals x because of this reason here. The function f is defined by f of x equals, goodness, 3x minus 6. This needs a bit of thinking, so it's 3x minus 6, and it's for all real values of x. Find the inverse function, f to minus 1, sketch the graphs of f and f to minus 1 on the same set of axes, and hence find the coordinates to the point of intersection of the graphs of f and f minus 1. So to find f to minus 1, we're going to let y equals 3x minus 6. Rearranging then for x, is going to give x equals, how to get that in its own, add 6 to both sides and divide by 3. So it's y plus 6 over 3. Therefore, f to the minus 1 of x equals x plus 6 over 3. Sketching the graphs of f and f to the minus 1 gives the lines then as shown. So let's get ourselves a wee sketch here. First one's y equals 3x minus 6. So if it crosses in at minus 6 and a gradient of 3, we're going to have a reasonably straight line going up here. So that's okay. Plotting this one, so this is a bit messier. We could rewrite that as a third of x plus 2. So this one then actually crosses at 2. And then it's a third of x, so it is definitely less steep. So let's see here, I think somewhere in and around this. Excuse my sketching, but we end up then with that. And again, if you look at the line y equals x, of course that's where the reflection is. And so that just goes straight up from there. Again, showing our little rule so that you can reflect it in the line. X. So this is our function y equals 3x minus 6. This is our function y equals x plus 6 over 3, and then that's the line y equals minus x. So the point of intersection of the two graphs which have been asked for is also the point of the intersection of the line y equals x. Can you see that? So that point there where it crosses, and we can work it out from there. Therefore, to find the coordinates of this intersection point, we just need to solve simultaneously the graphs of, so let's write that down to find intersection solve y equals x and y equals 3x minus 6. So that gives me x is 3x minus 6. That gives me 2x is 6, and x then equals 3. If you sub then x equals 3 into y equals x, you of course then get y equals 3 as well. So therefore the point of intersection then are going to be in that point there.